Okay, so one thing I want you to notice here we're going to help keep track of where this pattern appears is one thing you see is 3 is on the bottom and 7 is on the top. Well, when you rewrite it with the changed base, that's where 3 appears on the bottom, and 27, it's not really on the top, but it's still the higher number, right? So that's the pattern that I look at is the number on the bottom is the base, the number on the top stays on the top. Okay, so same thing here for log base 7. 7 is going to go to the bottom, and 49 is going to go, well, to the top, which is kind of where it was. So, okay, so let's talk about this rule. A lot of letters in there. Holy smokes, there's a lot of letters in there. Log base A of B equals log base C of B over log base C of A. Simple, right?
Simple.
Yes. So here's the thing, okay? C is any number that you choose. So if you're in base A, for example, the first question we worked on was base 3. We're trying to figure out 3 to what equals 10. So you don't have this base. If you want to change from base A into base any number you choose, which most likely will be 10, because that's the easy one for your calculator to do, you can change from base A to base C by using this formula. Now here's what you got to remember. The way I remember it at least is the number on the top. The number on the top goes to the top, right? So B is going to be the log of B, and A is going to be the log of A. It goes to the bottom of the fraction. That's how I know where they get split up. And C is any number you choose that's convenient. So most of the time you change the base so you can put it in your calculator. So let's try this one. Okay? So tell me, who goes to the top, who goes to the bottom?
30 goes to the top, 5 goes to the bottom.
30 goes to the top, 5 goes to the bottom. And what base would you like to choose?
10.
Sure, how about we do 10? Okay, so in your calculator, that's log 30 divided by log 5. What number is that? Sorry, Jack. 2.13. Okay, so what we just found out is we found out that 5 to the 2.13 is 30. Okay, so let's try and rewrite again. This time, let's be complicated, right? I mean, what's math class without being confused? Let's do Euler's number. Let's do the natural log. Okay, so I'm going to change instead of base 10. 1, 1. Close enough. Okay. Let's do log in base E. So that means I get to choose any number I want. So I'm saying let's do log base E. Okay. 10 goes to the top. 3.5 goes to the bottom. And in your calculator, this is the natural log of 10 over the natural log of 3.5. 1.83?
1.84.
84. 1.84. So yeah, that looks about right to me because 3 squared would be 9, so it's probably right around that number. So we're actually finding these exponents without those buttons. Okay, try the last one on your own and see what you end up with. Let's see here. Hari, do you have a changed base? Do you have a number here? I'll give you a hint. It's more than 5, but less than 6. Did you get it figured out? Ming, can you show her what you put in on your calculator? No, don't show her your calculator. I mean, show her how to put it in your calculator. So, Hari, you have an answer for us? What a good teacher you are, Ming.
1.6.
1.6? 5.15? 5.16? Okay, so again, you can choose any base you like. So you could write this as log base 10, which we don't need to write at 10. If you omit it, that's what people will assume you mean is log base 10 of 3907. divided by the log of 4.97. Okay, as long as it's the same base on the top and bottom, you can pick whatever you like. Okay, so let's try one.
Mine is so convenient.
1.8 to the x plus 2 equals 12. Well, we're wanting to know an exponent. Anytime you want to know what an exponent is, you're going to look for a logarithm. Excellent. So that means I'm going to rewrite this as the log base 1.8 of 12 equals x plus 2. Okay. I know I need logarithms because I want the exponent. If I rearrange this, the log of log base 1.8 of 12 minus 2 equals to x. That means the value for x, let's see here, log 12, log 1.8 minus 2. Yeah, so 2.28 is rounded to 2 decimal places.
Why is mine 2.23?
Oh, 2.23, yeah. It's because I need glasses. That's why. It is a 3. I rounded up the 7 instead of the 2. Okay. So another thing that you may find that the change of base rule is used for is sometimes you have to put logs which can be related to each other. For example, if I've got 9 and 3, they can be connected because 9 is 3 squared. So if I wanted to change these bases all into the same number, I can do that. And it'll end up giving me just one expression to work with instead of 2. So I'll walk you through the first one. I'm going to change these to log base 3. So log base 3 is what I want. Okay, so what goes to the top? Sorry if I'm not making it clear here. I'm working on this right now, the first piece. So what goes to the top of this fraction?
X.
X goes to the top, and 9 to the bottom, plus log base 3 of x. Okay. Now, is there anything else we can simplify? Nothing jump out at you as, oh, I know what that is.
Two times log base 3 of x.
2 times log 3 of x. How did you get a 2 in there?
Because there's
2 of them. Yeah, there's going to be 2.
No.
But first, before we talk about those 2 of them, what's log 3 of 9? 2. So I can say, well, why write that when you can write 2? Right? That's simpler. So let's write it down as a 2. That's log base 3 of x over 2 plus log base 3 of x. So if I had a common denominator here, I'd have 3/2 log base 3 of x. So there's only one expression now that I've worked with. Okay. So I'm going to get you to try the same process. Sorry, I'll keep that there. On this one here, for log base 2, 4, and 16, change them all to log base 2. Okay, so if I make a common denominator, I'll have 4 of those, 2 of those, and 1 of those. So that's 7 out of 4 log base 2 of x.